Okay, so you've had some time to discuss the vocabulary words for today. The first one that you had, I believe, was equivalent fractions, correct? Okay, Erin, tell me, what did you get for equivalent fractions?
Fractions that represent the same number.
Fractions that represent the same number. Haley, can you give me an example of equivalent fractions? Okay, Jocelyn?
4/8 and 3/6.
4/8 and 3/6, which all are representative of what? A half. Okay, they're both a half. Good, okay. Then you had the next one, which was simplest form. Jason, what's simplest form?
When the BCF of the number and the denominator is 1.
Okay, somebody else help me out. Aaron?
The following fractions were the greatest common factor of the numerator and the denominators.
Okay, Jocelyn?
The formula fraction of the GCF of the numerator and the denominator is equal to fraction 3/4. The equivalent form because the GCF of 3/4.
Okay, so we're finding the GCF of the numerator, which is the top number, and the denominator, which is the bottom number, and then creating a smaller fraction, reducing it down, okay? That is what we are going to be doing today, and in fact is our goal, our objective for today. It says I can use the GCF to simplify fractions. So go ahead and put this at the top of your notes page for today. Simplifying fractions. I can use the GCF to simplify fractions. Okay. Simplifying fractions. We're going to go through several examples. Two different types of examples. The first one will be where we're looking at fractions, we're comparing two fractions that we know are equivalent, and we're finding the missing number. And then the second type of example is I will give you a fraction and you have to simplify it completely, both the numerator and the denominator. Okay? All right. Examples. All right, and I want you to write it down exactly like how I have it, okay? First example, we have 3/8 is equal to something over 24. When you work on your assignment today, you're going to see this, instead of having an X, it's going to have a grayed out box. So right now we're doing this. So when we look at this, and I know some of you are probably already like, well, I know what the answer is. I want to talk about with this one how we get the answer. So remember when we were talking about division of decimals by decimals, and I talked about whatever you do to the outside, to the divisor, you have to do to the inside up to the dividend when we switch the decimal. And I even said, you might remember being told with fractions, whatever you do to the top, you have to do to the bottom, or vice versa. So something had to have been done to 8 to get 24. So Topanga, what was done to 8 to get 24? Times 3? Okay, so 8 times 3 equals 24. So we have to do the exact same thing to the top, right? So 3 times 3 is?
9.
9. So the way that this would look is 3/8 is equal to 9/24. Questions? Jocelyn,
I had the fraction colors on the right.
what's that?
I don't care.
When you write it with a slash like that, that's more of division. All right, let's look at another example. 4/5 is equal to 40 over what?
60.
When you think you've got it, raise your hand. Okay, Josh, what are we going to do here?
We're going to try to find 5
Why?
because 4 times 10 equals 40.
Because 4 times 10 equals 40, we've got to multiply 5 times 10, and we would get 50, which would be 4/5 equals 40 over 50. Good. Okay? Another one? Write this one down. When you think you've got the answer, raise your hand. Okay, Lindy, what do you think is happening here? How did I go from 15 to 3? By what? We divided by 5. So if I divided by 5 here, I've got to divide by 5 on the bottom, which is what? 5. Right. Good. So 3/5. 15 over 25 is equal to 3/5. Okay, one more like this. Raise your hand when you think you got it. So 21 over 28 is equal to something over 4. Helen, what do you think?
3 over 4.
Why? How did you get 3?
Because 28 divided by 7 is 4, and 21 divided by 7 is 4.
28 divided by 7 is 4. Therefore, we have to do the same thing to the top, and we would get 3. Good job. Okay. Now, I'm going to show you a fraction, and I want you to take 15 seconds and talk with your group about what you're going to do to simplify this fraction, to put it in its lowest possible state. Do you have a question or do you have an answer? Okay?
Do you got it on a note?
Just talk. You'll write the fraction down, but I want you to talk about it. Okay. Talk. Talk with your group. How are you going to simplify this fraction? Three, two, one, breathe. Good work. Awesome. Okay. So right away I heard some really good responses. Theo, what did you guys talk about?
We talked about making the 5 and the 201 until we want to.
And what are you doing to it by making that 10 to 5 and a 201? What are you doing to it, Kaylee? We're dividing by 2, okay? So if I divide both of these by 2, then I'm going to get 1/5. Now, Think about that 2. What would you say that 2 is when you're looking at the numerator and the denominator? What does this 2 have anything to do with it? What would we call this 2? The what? The GCF. It's the greatest common factor. You want to use, I'll wait for you. You want to use the greatest common factor to divide the numerator and the denominator by. Otherwise, if you use something else that's not the greatest common factor, if you just use a common factor, then you're not going to get the fraction in the simplest form. Alright? Let's look at another one. What do you think about this one? 8 over 25. Well, if you're not sure, then you can think about the greatest common factor like we did yesterday. And for this practice, I'm just going to do, I know we talked about several different methods yesterday, but I'm just going to list them, the factors. So I know that I've got 1 and 8 and 2 and 4. With 25, I have 1 and 25 and 5. Josh, how do you know that?
Because there's no common factors other than 1, which makes it the simplest form.
Awesome. Okay, he said it's already in its simplest form because there are no common factors except for 1. And if we were to divide this by 1, we'd get the same thing. So 8 over 25 is already in its simplest form because it has no other common factors. Good. Questions? Good. Okay. Let's look at the next one. Some of these you might be able to see the GCF right away. Some of them you may not, and you would need to list out the common factors. When you think you know the GCF, raise your hand. Gabby, what do you think the GCF is here? 2. Okay? Because if we look at 10, 10 only has 1 and 10 and 2 and 5. Well, if I remember my divisibility rules, this number has to end in a 5 or a 0 for 5 or 10 to even work. This is an even number, so 2 will work. So if I divide both of these by 2, what is my new fraction in simplest form? 5 over 19. Good. Questions about this one? Okay, here's the next one. I want you writing this down. Hey, Will, what do you think?
The GCF is 3 and it's 5/15.
Okay, Will says the GCF is 3 and it's 5/15. So if I divide both of these by 3, then I'm going to get 5 over 15, right?
Yeah.
Oh, I've got some people shaking their head. They're like, no. Oh, so the original one here? Oh, okay, so here we've got one. Oh, you got to divide by 5. All right, so now I'm going to divide this both by 5, and, well, I'm going to get 3 over 9. Well, this has gotta be it, right?
No.
No, Carol, what can I do?
Divide by 1/3.
Divide by 15? What? Okay, let's see. Let's see what happens. 15 over 45. So I divided both of these by 15. 15 goes into 15 one time. 15 goes into 45 3 times. Now look up here. Look, if we pick this original one, I could still divide out by 5s, right? Look, they both end in 5. 5 will go into 5 one time, 5 will go into 15 3 times. Here, I could still divide both of these by 3.
But they're still all 1/3.
Right. Very good observation. These are all equivalent fractions. Starting with 15 over 45, going down to, then simplifying it to 5 over 15, or simplifying it to 3 over 9. Ultimately getting it down to 1 over 3, or 1/3. Okay? So this is what I was talking about. Well, you know that 3 would work and 5 would work, but when you look at these, what you get is, after doing that, those can still be reduced down. Now, there is nothing wrong with maybe taking 2 steps to get there, but it is better to do it, just 1 step, use that GCS, and go from there. So, if you need to, over in your scratch work, list these 2 numbers out, find the GCF like we did yesterday, and that's what you're going to use to divide into both of these numbers. Make sense? Where are you lost? Talk to me. Okay, let's do another one. I want you to write this one down, and I want you to solve it on your own before we talk about it. Write it down. Simplify it as best you can. If you're not sure where to start, think about yesterday. You fit 48 and 60 and find the GCF. And use that to divide into both of the numbers. Hold on, So if you're not sure where to start and you're looking for the GCF, then you write those down, and if you want to use division ladders to do that, maybe you prefer that method. Okay, Talon, walk me through this division ladder.
So, 2 can go into both of them, and then that's 24 and 30. And then I did 3 to go into both of those, and I got 8 and 10. And then 2 can go into both of those again, and it's 4 and 5, and then I multiplied it, I got 4.
Okay, so remember when we're down here, we're done, okay? Because we've got a prime number here. And this 4 is unique to this row. So 2, 3, and 2. So 2 times 3 is 6, and 6 times 2 is 12. So the GCF for 48 and 60 is 12. Dylan.
The 48, I didn't get a 3.
I'm sorry?
I didn't get a 3 on 12.
And then you didn't get a 3.
I did the
Okay, so you used prime factorization. So what 2 numbers did you use?
6
Huh?
and 8.
6 and 8? How did you split up 6?
3 and 2.
So you did get a 3.
Oh, yeah.
Good. All right. All right, so then I'm taking these 3 and multiplying them together, and I got 12. Yes, ma'am. Well, that's very interesting. I wonder if that's going to work out each time. So if we divide that by 12, we get 4/5. And Hannah said, well, it kind of gives you an answer when you look at this and you put a line between them, it makes 4/5. Now, I wonder if that was
That's
just
what I
a
did.
fluke?
I did that, like, for that one, and it was for, like, all of them pretty much. It worked for all of them. Like, the last two numbers I got.
Let's try another one. Let's try another one. Let's go with... We'll go with an easy one because I want to see if this, we're going to test this theory, okay? So if we're looking at division ladders, and we do 25 and 75, let's use 5. 5 will go into 25 5 times, and we'll go into 75.
12?
15 times. I can still go, use 5, and go in 1 and 3. 25, so 5 times 5 is 25. It does. 25 divided by 25 is 1. 25 divided by 75 is 3. Interesting. Milan?
I used to use 5.
I know, yeah, and you could have used that too. That's fine. There's nothing wrong with using 25. That's very interesting. We'll have to keep an eye on that, because if that's true, that's a way to check yourself. Do you guys see this, what we're looking at?
Yeah.
Okay. All right, any questions before I give you your assignment? Okay. You are going to be working on page 207. Numbers 10